All right, so we're going to start the first series of reactions that we need to talk about. I've removed a couple of them to make our lives a bit easier, but halogenation is definitely one of the most important ones that we're going to look at in industry. I'm going to focus mostly on substitution reactions, but I will mention an addition reaction that can come up in your research if you're looking a little bit outside of this, and that's fine as well. But the main thing that I'm looking for in your checklist is 2 of these reactions correct. So a reaction of benzene, toluene, phenol, or aniline with bromine, chlorine, or bromine. I don't like that now that I've said it, so I'm just going to stick them all to be bromine. There we go. So these are the main ones we're going to talk about. I can do chlorination later on. I want 2 of these reactions where all the reactants and products are named correctly and drawn, and solvents and conditions are stated, but I'm going to take you through them as a general idea. Remember, you only need 2 of the reactions above and just the ones you've been assigned. So if you've been assigned number 2 and 4, you're going to be doing this one and this one. If you've been assigned 1 and 3, you'll be doing these 2. If you've been assigned 2 and 1, these 2. Right? So you only need to do 2 of those reactions, and I would do it in line with this. So this will be the first one that you do. This one will be the second one that you do. Just need to make sure that they're correct. Let's get into it. So depending on which of the derivatives that you have, there are 2 types of reactions that we tend to see most often. That's the way that I'm going to word that. If, for example, you're doing a toluene or a benzene, you're looking at this type of reaction where we have what we call a mono-substituted reaction. We only have 1 substitution. If you're looking at a phenol or an aniline, you're looking more at this reaction where we get 3 substitutions instead of just the 1, and the ring is maintained. Now I'm going to give you a bit of information about this, just so you have an idea of what to write, because remember, not only do you need to do the reactions, but you need to explain to me how a halogenation reaction works with a benzene derivative. So the main thing I wanted to mention is that when we do a benzene derivative reaction with halogenation, we're looking at substitution. We know it's substitution because in the product, the ring is maintained. So if you look at the start and look at the end, the ring is maintained in both. If the ring is destroyed, then you're looking at an addition reaction, which is a different type of halogenation reaction. It's not incorrect, so if you do draw an addition reaction here, I will accept it as long as it's correct. However, the substitution ones I got is going to make your life a lot easier. If you remembered from before, the benzene will not react with bromine under normal conditions, and that's where we need something called a halogen carrier. These are catalysts, but AlBr3 and FeBr3 are the most common. If you remember with the benzene ring, it's a delocalized ring of electrons, and in here, what we have is it results in a lower electron density, so we have less electrons dense in these points, which means that this can't attack the ring, which means we can't really do a substitution. So we need something else in there to make this react. Now, benzene will only react with halogens in the presence of a halogen carrier, such as the AlBr3, which produces a more reactive electrophile, which is Br+. Now, we're going to look at Br+ in the mechanism section. Yes, it is Br+, not Br-, which you guys are familiar with. Br+ does exist. And it is an electrophile. Remember, you guys noticed the difference between electrophiles and nucleophiles. In this, we're looking more at electrophiles. So we're going to be looking at electrophilic substitution. The reaction here is electrophilic substitution. A halogen carrier is required for anything of these 2 derivatives. So a methylbenzene or a normal benzene, you're going to need these conditions right here. You need those conditions. And plus probably a bit of heat. So your halogen carrier and heat. This is for benzene and methylbenzene. Remember, for benzene, X1 would just be a hydrogen. And for methylbenzene, X1 would just be a CH3. And then that would be the same in your product. Now, if you're looking at phenol or aniline, this is for you. So for phenol or for aniline, we don't actually need a halogen carrier. So we don't need AlBr3. We don't need it. We probably do need a bit of heat, though. So we need a little bit of heat, but because we have the OH here, or the NH3. What that does is that the lone pair gets delocalized into the ring. It makes it more electron dense, which means this can then finally react with it because it has a higher electron density. So the electrophile is now more strongly attracted to the benzene derivative, and it can triple substitute actually quite easily. And then you're going to have this product here. Remember, if you've got an alcohol, you'll have an OH, so you'll have a phenol. Or if you have an aniline, it'll be an NH3. Sorry, NH2. Now, in terms of naming them, this is how you're going to be naming them. So over here, you've got your bromo derivative. That's going to be for the first two. So if you just have benzene, it'll be bromo and then your derivative. If you have toluene, bromo, your derivative. Or if you're looking at 3 and 4, this is how you're going to name your one. 2, 4, 6, tribromo, and then your derivative. And that's simply how you name them. These are the conditions that you need. These are the reactions that I want. And then I want some explanation of how the halogenation works. So obviously, if you're talking about this, you need to explain that halogen carriers, why it can't react, just the information that we mentioned before. And then if you're talking about these ones, why you don't need halogen carriers, and that's because the electron density is donated into the ring. It makes it more electron dense, which means the bromine is more likely to attack it, and therefore substitution can take place. So you're going to be looking at some form of information there about these reactions. Remember, everything needs to be named correctly. And this is how you name them. Should be nice and easy though. Keep up.